क्या बोल रहे हो यार? RLHF रैग, हाँ मतलब दैट वुड हैव बीन अ मच गुड क्लोजर, मच बेटर क्लोजर। नहीं ज़रूरत है वैसे, देखो ज़रूरत तो नहीं है ना। और हाँ ठीक है, एग्ज़ाम पर्सपेक्टिव से तो यही ठीक रहेगा। So then तो I should even change my track. I don't know because हाँ हैंड्स ऑन देखो व्हाई आई गेव अप, क्योंकि प्रोजेक्ट में वो कर ही रहे हो राइट। हाँ एंड आई सीरियसली डोंट थिंक कि उसकी मेरे को कराने की जरूरत है, बिकॉज अपन एक एक चीज को डिटेल में लिया है। सो आपको कोई कोड ऐसा है ही नहीं जो साला समझ में नहीं आए। हाँ आई डोंट थिंक यू कैन एनकाउंटर एनी कोड ऑन ट्रांसफॉर्मर्स जो समझ में ना आए। बल्कि इट विल लुक ट्रिवियल, सो नॉट जस्ट कि समझ में नहीं आएगा, इट विल लुक वेरी ट्रिवियल कि वी नो हाउ टू डू दिस। सो यार जो बात बोल रहे हो उसके हिसाब से तो आई नीड टू चेंज गियर। I had thought of at least 4 to 5 lectures on RLHF. मतलब not at least 4 to 5, at least 3, but up to 4 5. अपने पास क्लासेस कितनी है? हाँ फ्राइडे छुट्टी है? नहीं कल मैं छुट्टी पे हूँ, कल मैं छुट्टी पे हूँ। सो देन आई शुड डू इट इन अ मैनर कि अगर आज लास्ट क्लास भी हो तो दैट शुड बी ओके। I'll take classes anyway because मेरे को since I'm uploading it online, so मेरे को I have to do it a closure, but so let us see how does it go. मेरे को इतना पढ़ना पड़ा है ना, I didn't know कि RLHF पे इतना, so you know there is one GPT, उसके corresponding में a couple of RLHF papers for that, so GPT-2 and a couple of RLHF papers for that. So एक ट्रैक इनका OpenAI वालों का इधर चल रहा है, दूसरा ट्रैक चल रहा है RLHF पे, and huge amount of effort going in there. This is something I was not aware of. All right, so let's start. हाँ हर दिन, हाँ वीक गलत बोले थे तुम। अच्छा दिन ही बोले थे। लिंक्डइन भरा रहता है एकदम, और लिंक्डइन जिन लोगों से भरा रहता है वो सारे ऑथेंटिक लोग हैं, उनको तो मतलब इग्नोर भी नहीं कर सकते हो। एंड देन आई एम फॉलोइंग 2 लाइन्स ऑफ वर्क, एक रेगुलेटिंग एआई, एक ये। सॉरी हाँ हाँ देखो मेकिंग एलएलएम फ्रॉम स्क्रैच इसकी बहुत ज्यादा वैल्यू है, डोंट वरी अबाउट दैट, है ना, डोंट वरी अबाउट दैट, बिकॉज लोग बहुत कम है इस टाइप के, अभी करंटली हाइप पे ज्यादा चल रही चीजें, है ना। सो आई डोंट नो कि जो मैं सोच रहा हूं इस कोर्स का आउटपुट वो एक्चुअल में कितना हो पाएगा आप लोगों के लिए, बट आई स्टिल बिलीव कि this will help someday, I don't know when, if not immediately. Okay. All right, so then let us start. So I need not write date today, or so this is something that we had done. Right. So so there was a question in the last class that why this is not bidirectional, right? Now, so actually this could be, but the thing is the one who gives you this thing need not be same as this human. So the person need not be the same, right? But in the end, which state you go into next. So this will get much more clear with when we proceed. Okay, probably that question itself will go away. Now, so coming to the next set of paper, which is supposed to be the first one, in the line of RLHF for ChatGPT. So something that led to ChatGPT, and I should write the title of the paper. So the paper is, what is the date today? 16/04/2024. So the title of the paper is so deep reinforcement learning from human feedback, and again this is Cristiano et al. From OpenAI. Okay, not OpenAI, but OpenAI DeepMind. Okay, so OpenAI DeepMind, that is it. So there were times when Google and OpenAI were working together. 2017 paper, and this paper actually laid the foundations for RLHF for ChatGPT. So in this paper, what they propose is, so you have this RL algorithm, and what happens? What will this guy do? What will this guy do? What did we do in this figure? So earlier we had an agent that will interact with environment. What did we do in this figure? We separated out a human being, that it is not environment. So the key takeaway from this is just one. The environment is not going to give me reward, but there is a separate human being that will give me reward. Environment is just going to get me the next set of observations. That's it. Okay. Now we go next. What this paper says is, so that this particular paper refines what we just did. It says there is an RL algo. So what will happen? You have an environment here. Okay. Now environment, so this guy sends you what? Actions, and then this guy sends you back something called observations. Okay. And This is environment. So what you have here is a reward predictor right. So, how is this different from what we had just drawn above? What change they bring? How is this different from the previous one? See, there you had this RL agent interacting with environment, that was our original RL. Then we said environment, so in originality what does environment give me? State or basically observation and reward. We said separate these two, environment is only going to give me the observations and reward will be given by a human being. In this we are saying human will give its feedback. So, we will train from human feedback a reward predictor. This is the same old RL setting. So, my agent interacts with environment, environment gives observations. Note that environment is still not giving me what? Reward. Reward is coming from somewhere else. Okay. So, there is a reward predictor. So, you basically want to approximate the human behavior, that what human is going to give me. So, one thing I have missed out. Yes. So, these observations also go here, right. So, from these observations my reward predictor is going to kind of tell me what is the reward I should get, and keep on doing this. So, what are you doing essentially in this case? So, see, essentially this paper gives you one thing, that they try to explore goals defined as human preferences between pairs of trajectory segments. Okay. So, they have this reward function to model humans' preferences. Right. Questions here? Right. Next. Okay. So, by the way, any idea how does ChatGPT work? So, we are just left with this last thing called RLHF. How? What do you think is wrong with GPT-3 alone? Huh? So, why do you think we need to do RLHF? Why is GPT-3 not sufficient? We have talked about this before. Right. Right. So, GPT-3 are very good models for predicting next token. They are very good at that, but they are not aligned with human values. So, and internet is full of garbage, right? Full of biases, full of everything that might be wrong. So for example, you don't want your model to answer when you ask it how to make a bomb, for example, right? But jailbreakings and all these things are possible, but in principle, this is what we want our LLMs to do. So what I'm just going to write all these steps here now. So I'm moving away from that paper and I'm directly going to instruct GPT paper. Now instruct GPT paper says you have prompts. So this training GPT through RLHF has actually 3 steps. So I'm going to write this step 1 for you. Okay. So prompts and text data set. Now what do you do is you train a language model. What else? It says you have okay. So I'm just going to read this from Instruct GPT. Collect demonstrations data and train a supervised policy, basically supervised model. Okay. So what is happening in this figure? What is happening in this figure? Dekho, what we are doing here is you simply train a language model. What are you doing? So what was my GPT-3 doing? Just take causal language modeling, which is I just want to predict the next word. And we don't want GPT-3 alone because it is not aligned with human values. We have seen that the output of GPT-3 were not same as what human asked for. So for example, what was that example? We asked explain, what was that thing? Explain to a 6-year-old boy how to land on moon or something like that, right? And then it started completing like explain something to 6-year-old and so on. All those responses were coherent, grammatically correct, but this is not what human wanted them to answer. So what we are saying here is you have some prompts, you have text data set, you train your language model on that particular data set as well. So you have a pre-trained LLM that knows how to predict the next token. What you do is you write some prompt. What will be the answer to that prompt? So prompt, answer to that prompt, prompt, answer to that prompt, and you train this LLM. Okay. Human augmented text means when you generate something, human can actually go and change that. Okay. So my LLM generated something, human can actually go and change that. See, this is not what you should have generated, you should have generated this one. And OpenAI has actually invested millions on this. So when I was reading about this, and this is something I was completely unaware of. So there was a separate line of research going on where they are hiring human beings to do all this kind of prompting. Okay. So you have a prompt is sampled from user from our prompt database. A labeler demonstrates the desired output behavior. This data is used to fine tune GPT with supervised learning. So this is what I have just drawn here. Any questions in this or shall I repeat? See, a prompt is sampled from our prompt data set. A labeler demonstrates desired output behavior. So a labeler tells us what is the desired output behavior, right? And this data is used to fine tune GPT-3 with supervised learning. There is nothing new that we have seen here. We have been seeing this. You train a LLM on causal language modeling, and then you fine tune it here. So here what is the task for fine tuning? Give a prompt, right? And in that prompt's response, human has written the answer. So we are fine tuning on this. This step 1 is over. Okay. Now step 2. Okay. Yes. Where? In this step, all we are doing is training, right? We are not talking about the outputs as such right now. Step 1 simply says there is a prompt, there is a corresponding text data set, and I am going to train my LLM with, if required, human augmented text too. So there is a prompt and there is an answer given by human being. This should have been the answer of this. Okay. This one? When? See, question answering is a different thing. So let's say if you, so question answering that we have seen until now was of this kind. There is a big comprehension and you ask question based on that, right? So what my BERT model or what they will do is, they will give me start and end, right? So that is very different from what we are doing here. Here I can give you an open-ended thing to do and you are supposed to answer, right? So second step is reward model training. I'll send you links to these slides and videos so you can go through them as well. So reward model training now. What we are doing in this case is, you have a prompt data set, right? Now so you have a prompt data set, sample many prompts from there and feed it to my language model. Now this generates some text and now you do human scoring. So you have generated some text and these are various texts that my LLM has. So outputs are ranked relatively. And then what you do is, this generated text and these outputs, you feed it to this right. So right. See, you have a prompt data set, you sample many prompts from it, okay, and you train a language model. So this is what we have. You give it, sorry, training is done, you give this to language model. Now language model is going to generate some text for you, okay. Language model generates some text for you. These outputs are ranked relatively. So what does that mean? Outputs are ranked relatively. A is better than B is better than C and so on. So see, earlier, I mean, the way it all started, you wanted to just say thumbs up and thumbs down, and it so turns out that that is not the best way of human feedback. Human feedback, as they say in this 2017 paper, which was deep reinforcement learning from human preferences, they say, see, human beings are bad at this. So if you ask human beings, rate something out of 10. So whether to give 6 marks, 8 marks, 2 marks, we are bad at that. But if you give me 2 things to compare, then I can, with much better accuracy, I can tell you that this particular instance is better than this particular instance. So if you ask me to compare, human beings are much better, but if you ask them to rank absolutely, that provide some numbers, we are bad at that. So this task was abundant, stop giving numbers, rather what we are supposed to do is compare 2 things, right. Now ChatGPT further, InstructGPT further evolves and it says ki don't ask for just comparison between 2 things. Ask humans to compare across few, let's say 4, 5, 10, whatever, that A is better than B, is better than C, is better than D and so on. So you ask your language model to generate something, it generated things for you. Once it generates things for you, you are supposed to, as a human labeler sitting out there, is going to rank these outputs that my LLM has generated, okay. These rankings, so now we train on sample and reward. So reward model is now going to get trained. What is my reward model now? So this step 2 in InstructGPT paper is collect comparison data and train a reward model. So a prompt and several model outputs are sampled. One prompt and several model outputs are sampled. A labeler ranks the outputs from best to worst. This data is used to train our reward model. Questions here? So I have a prompt. So I have a prompt. I generated 4 outputs for it, right. So on first one, my output will be whatever. So my prompt, I have 4 outputs. Now depending on how human has ranked it, right, you try to learn a reward function. We don't know what is that function R that is going to map. So when I generate something, you need to give me some output, you need to give me some reward. Let's go back to first principles. How does RL work? Agent does something, it's okay. Agent does something and environment gives you observation and reward. Here what we are saying, agent does something, it generates text in response to my prompt. What is human doing here? Reordering those outputs, and then using this you are going to train a reward model. So nobody is actually giving you a reward. What you are actually doing is, you are learning a reward function in itself. And why do you need to do that? This reward function, so basically you are using this output, right, of the human process to train this reward model. So for example, my so let's say I have sampled one prompt and I have asked GPT to give me 4 references, right. So it gives me 4 it generates 4 things for me. Now, human says A is greater than B is greater than C is greater than D. So, what should I learn from just from this? What do you learn? That output A was better than B, was better than C, was better than D. So, that means what as a LLM, what should I generate? I should generate something that is closer to A and maybe farther from D, right? So, every time you generate something, human is going to tell you, see this output was better than this one, then this one, then this one. So, your reward model starts making sense of this, okay, out of these 4 examples, this was the ordering. Out of other examples, this was the ordering. So, it starts learning what? A reward model. Reward model means, so see, you have to reward LLM for generating output. And do we know what is this reward function? Is this some, R square or something like that? We don't know what is it. We don't know what is this behavior of reward function. That is precisely what we are trying to learn. So, what we are simply, see, if you break this down, just these 2 things. So, let me go through this. So, prompts for specific use case model will be used for chat questions, much smaller than original training. So, fine, this part is done. I don't think I have left anything, but let us see. So, and it turns out that they keep this one also a transformer based neural network. Okay. And if I remember it right, for Instruct GPT, this guy itself was 6 billion parameter model. Okay. Questions here now? Yes and no, but depending on what you want to further ask. It is a fine tuning method because see the point here is GPT. So, what is wrong with GPT again? GPT's objective was to generate next token. So, GPT is fantastic at that and does well. So, if you just wanted GPT to do that, stop there. But you want to be able to interact with the bot that gives you useful answers. So, now question, and should that be toxic? So these papers, they try to capture these things. So, my output generated by LLM should be helpful, should be harmless, and should be one more thing, triple H. So, harmless, helpful, honest. Okay. So, if your LLM does not fit into any of this, what do we call it? It does the 4th H, which is hallucinates. Okay. So, if it makes up things on its own, hallucinates. If it is harmful, toxic. If it is not helpful, then useless, right? So, and how do you capture a metric for this? So, you want your model to generate next token, but you want your model to generate next token such that it is helpful, honest and harmless. So, whatever you had trained on, whatever your training objective for GPT-3 was, is it aligned to these 3 things that we have added just now? No. It was trained on a super big corpus from the internet which can contain anything as long as it is English thing, right? And then generate next token. It can be toxic, it can be not helpful, and it can be made up, right? Because everything that is on internet is not a fact, everything that is on internet is not harmless, and everything that is on the internet is not helpful either. So you have trained on something with an objective that has nothing to do with these three triple H, I mean these three H, right? You want generating next token was not helpful, we have seen. GPT-3 was, giving the right sentences, but what do I do with them? That is not being helpful to me. So I want it to be helpful, harmless, honest. My question is, give me a mathematical construct that captures these things. So give me a function that captures helpfulness. We can't. So when we can't come up with these things, what we start saying, that is what this 2017 paper says, that okay, we can't really model these complex things. What we can say is, we'll start training on human beings. I mean, we'll start taking feedbacks from human beings, and we'll just tell our LLM models, see, this output was good and this was not. The reason might be it was not helpful, it was toxic, it was made up, whatever. But right now I am not giving you reasons which category does it fall in. I am simply telling you A is greater than B is greater than C is greater than D. Now, why can't you do this first thing that I just said before? See, human feedback is very expensive. So OpenAI had hired people from North America, people from Southeast Asia to label all these things. And in the paper just before Instruct GPT, where they try to summarize things using the same technique, it turned out that researchers at OpenAI and labelers sitting throughout the world. So they were working specifically on this problem of summarization. So the task will be, this is the text, now summarize it for me. And I am going to test it on a Rouge metric, ROUGE, right? But let's not get into there now. So human labelers, they don't know about this training process. What they are supposed to know is, this is English and this is toxic, this is helpful. So this every human can do. I don't have to be a deep learning engineer to be able to do this. There was a prompt and I am just supposed to rank prompts. I can do that as long as I understand English and has a reasonable understanding of the world, right? So give it to them. The users were given, so they labeled everything. Whole thing went to OpenAI researchers. They said what labelers are optimizing is not what we wanted to optimize. So this Rouge metric, what it does is that it does similarity check between the original document and your summary. So if you are able to copy well from your original text and make a summary of it, then that metric will perform very good. But when you want to summarize, what is it that you want to do? Particularly from a LLM, see, you want your LLM to generate things. You don't want it to copy paste, some sentence from here, some sentence from, even if it summarizes my document well. I don't want you to copy piece of text. Rather, what I want you to do is, I want you to generate. Now, what these labelers were doing, they thought these are good summaries because my Rouge matrix gives me a really high score. And researchers said, no, this is not what we wanted. What we wanted was, you should be able to generate things on your own. So they had to, So in the next iteration before instruct GPT, what they did was, the researchers, they improved their GUIs and all that playground that they were using, where they will give much more feedbacks to labelers. See, this is what we are looking for, this is how you should do it, and there was a much more interaction between the OpenAI and labelers team. Finally, when they were able to come up with this thing that okay, A greater than B greater than C greater than D, right? Then this instruct GPT was trained, which happened to be much better than their previous versions, and which finally gave rise to chat GPT. So what is the key takeaway from this one? So your LLM is going to generate things, humans will do what? Rank them, right? Just rank them, don't tell me whether it was helpful or it was honest or whatever, just rank them. Based on this ranking, what my reward function will do, what my reward model will do. So I am supposed to train a reward model now, that see, humans are saying this is better, this is better, this is better, and this is not so good. So we want you to learn a reward model that given a generation by my LLM is going to give me a reward, and based on that reward my LLM will kind of get an idea whether whatever I have generated is okay or not so okay. So reward model itself is a transformer based language model, variations in size. So what I remember, it was 6 billion. Now we come to fine tuning with RL. So fine tuning with RL. Okay. Now okay. So this is what we have done now. Now fine tuning with, so this is an important thing. Now see, if you train your LLM, How does RL work? So RL, heavily depends on this one scalar called reward, and it just tries to maximize the expected utility of that reward. That's all it does. The thing is, so I mean, I won't go into the details of this, but generating longer text is a less rewarding thing. Why? See, if you generate longer text, the probability that you will make mistakes actually increase. So let's say if you want to just train a RLHF model to generate questions, what will it do? You want to train a RLHF model just to ask questions. What does it start doing? It starts generating questions like what, why you, what is, and so very small questions that actually don't make sense. And why does it do so? Why does it do so? Because your rewards will be higher for these things. So the question here is, if you take prompt data set, if you fine tune LLM, what this guy starts doing is, it starts ignoring the, see, you trained a LLM first that knows how to train the, how to come up with the next token. So you did that. Now you trained RLHF that gives you rewards. So this reward thing starts dominating and your LLM actually starts outputting bad sentences. Bad in the sense that those that are highly rewarding in that sense but are actually useless. Okay. So how do they mitigate this? What they say is, don't just train a language model like that. So you have prompt data set, you have this language model which is tuned. What you also have is, you have your initial LLM. These two guys, they are going to give me, so maybe I'll write it here. So don't go for this. What we actually care about is this thing, pi what this equation actually captures. What this equation actually captures is, what is this? See, pi is basically policy, which is nothing but my LLM. So this is my LLM base. What is LLM base? For example, GPT-3. Okay. So GPT-3 without contaminating it with RLHF. What is this guy? What is this guy? This is GPT-3, but after fine tuning on prompt data set and then RLHF. Okay. What was this guy good at? It generates the right thing. It is going to generate right English text. Why did we bring RLHF into picture? Because a syntactically and grammatically correct English sentence does not mean it is helpful, harmless and honest. So we brought this thing into picture, and bringing RLHF has a side effect, which is I start artificially gaining rewards by doing things which a language model will not do. So asking questions like what, why you, and so on. So a language model will not ask such questions. So what you do is you try to bring this equation into picture, right? So in your reward model you add this thing. So before this you have a reward model. So you were trying to maximize that reward model. Now you minus this thing from there. What is PPO? The optimization algorithm that they are using for this RLHF. This is all we need to know. Pi base is my original LLM. So here all we are simply saying, so this is my RL, this is my RL, and this is my LLM, and this is RL plus LLM. What we are saying here, this thing should not differ very much from what your original LLM would output. What my original LLM would output, it will take care of semantics, right? It will be a right English text. What about this guy? This guy takes care of the fact that my output should be closer to helpful, harmless and honest. But because of this artificial reward function, it starts behaving in a weird manner. So to address that, what you say is, whatever my RLHF model will generate should not be too far from what my LLM will generate. So because LLM outputs are pretty good, the only problem is they are not helpful, harmless, honest. You bring in those qualities, but that has a side effect of generating things which are not syntactically correct. So what you force is, whatever you generate after RLHF should be not very different from what original LLM would generate. So you try to minimize that distance. Now this guy cannot generate things like just what. It has to write the whole questions. There is a whole set of examples where this guy starts doing actually much better. Okay, so you have this now. Now reward model, right. Okay, so you have this your reward model, you have this thing coming from here. Now you give this back to RL update. Okay, so right. So what you finally do is, you have this reward model. This reward model, so when you want to update this reward model, you essentially take this thing into account as well. This is what this is saying. Okay. So we are done with just one figure of Instruct GPT, figure 2 I think. Yes. And that describes the whole training process for RLHF in Instruct GPT. So tomorrow I am on holiday. Friday ko, so tomorrow is which date? I mean which day? Wednesday. So we'll have a class on Thursday. And then we'll have a class on Saturday. Saturday is Friday, na? This Saturday is Friday. Anyway, so I'll be teaching RLHF in much more detail because I need to close this well. So if you want to come, you can come, but that is not part of your end term. So I think it's a good place to close things for end term. Of course. नहीं पूरा आएगा. I think this is a right place to close. बाकी तो दूसरी चीजें. But I need questions here. Ankur can wait today. Yes. No. This needs details, right? But what we are saying here in words is, if you just learn a reward model based on RLHF, that is not sufficient because it has some side effects which are very crucial. Things like it starts generating things which are highly rewarding but are not the correct, I mean not what you want. So basically not good English sentences. Okay. So if I ask you to generate questions, you start generating what, how, they are questions but they are useless questions. So then it says whatever question you generate, that should be very close to what my LLM would generate. I want to use RLHF only to remove toxicity, right? All those things. But I want my language structure to be preserved. So in training reward model, take care of this guy as well. This is all we are saying in this figure. Okay. I think that is it for today's class and that is it for this course as well. So thank you and बाकी जब भी extra classes होंगी, I'll send a message anyway. Okay? चलो. जब ये कोर्स शुरू किया था तो मेरे टेबल पे कुछ पेपर्स नहीं थे. आज इतने पड़े हैं वहाँ पे.